So welcome to my talk. We're going to talk about automated machine learning on Azure. Can everyone hear me at the back as well? Brilliant. Thanks for the thumbs up. Okay, just before I delve into my talk, just to introduce myself really briefly. I'm not going to go into much detail. My name is Kavita Raghunath. I'm a principal data scientist with Advancing Analytics. We've got a booth here today. So if you don't know who we are, we pretty much a UK-based consultancy, right? We do anything to do with data engineering and machine learning. Those of you who know Advancing Analytics probably recognize that little badge with Simon on it saying, "Hello, Spark fans." He's produced hundreds of technical videos. We've expanded recently. We've got a bit of machine learning videos as well, and we've got a bit of Power BI as well. Really cool resource if you're looking to start in terms of data engineering, Spark, and machine learning. Cool resource on YouTube. One of my favorite things is Totally Skewed. Totally Skewed is a podcast that Advancing Analytics produces, and we talk about anything to do with pretty much data. It's called Totally Skewed, and those are the contact details for the company. Apart from when I'm working as a data scientist with Advancing Analytics, I do quite a lot of community work as well. I'm a Women in Data Science Ambassador that's based globally in Stanford University. We are also part of the Women in Data organization, and I'm an AI MVP. So machine learning is on the rise. If you've seen the keynote before, there's mention about ChatGPT. Don't really need to put these figures up here really to just show that machine learning is definitely here to stay. In fact, if you look at some of the resources, which are pretty old now, in 2022, 84% of CEOs say that AI and ML are pretty much very strategic in their organizations today, right? And if you look at what Gartner predicts, up to 2025, they've predicted $5 trillion in terms of what AI and ML can generate in terms of business value. But that's just the media. So if you look in the media, there's a lot of hype about AI and machine learning, right? But the reality is, if you look at the tech world, tech leaders are still racing to move to the right-hand side of the data and AI maturity curve, right? So I like to show this curve, and what I like to talk about is getting a real-world example here, right? So imagine if you run a business trying to do some sort of forecasting, or you've got a shop and you need to forecast products. If you're in the left-hand side of the data and AI maturity curve, that's very much in the reactive zone. That's very much if you had not sell a product really as well as you intended to sell. You'd probably go and get some data, gather some data, clean the data, do some reporting, and try and understand why you didn't sell that particular product as well. But if you were to move towards the right-hand side of the data and AI maturity curve, your step ahead would be trying to implement some sort of predictive modeling. And by that, I mean trying to build some sort of AI and machine learning. And with that, you then tend to understand what will happen, right? You're trying to predict when you're going to sell certain products. So that's predictive modeling. And if you move on even more, then you get into the prescriptive analytics part. So if you have an AI model that's able to predict in future for you, then you can then figure out how you should respond as an organization or as a business. Now, this is the ultimate data and AI maturity, where you've got all those things implemented. You're pretty much on the left-hand side of the data and AI maturity curve, where it's making your decisions automatically for you, right? You understand what's going to sell, what's not going to sell. You understand why it's not going to sell and how you should respond, and make those decisions automatically for you. And that's what gives companies, organizations that competitive advantage. Brilliant. But what is the real current state of AI and ML at the minute? It's not as positive, right? There's lots of ambition to move towards the right-hand side of the curve. But if you look at the slide, and this is not my figures, these are figures published by independent reports, companies are still struggling. And the reality is, some companies have implemented some AI, some companies have not implemented any AI. So there's many reasons, and some of the reasons are shown on the slide. You've got data, having data source, having clean data, having enough data to do any sort of ML is important. Having siloed data teams just doesn't make data and AI work anymore. That's very traditional. So moving away from siloed data teams is a challenge for most companies. Having disparate technologies where there's so many open source and proprietary software available for different types of role, for data engineers, for data scientists, for your business analysts, and they don't really talk together really well. They don't communicate. That's another challenge, right? But today what we're going to talk about is how do we address the challenge of having the lack of machine learning expertise in organizations that companies just pretty much struggle with at the minute. To kind of address that fact in terms of lack of machine learning, we're going to look into AutoML. Really wordy definition of AutoML was coined about 11 years ago now. And really, if you look at it, automated machine learning, or AutoML, stands for the process of automating machine learning tasks. So when you talk about machine learning development, there's set phases and set cycles. And AutoML, what it tends to do is just tend to automate everything behind developing a machine learning model. Now, most cloud vendors would offer AutoML. In fact, I don't know of any software at the minute now, if you're looking to do AI and ML, that don't offer AutoML. But to really understand how AutoML can help, let's have a look at the machine learning lifecycle, right? If you were to develop a machine learning model, you'd start with some raw data, okay? Then you'd go through the process of cleaning your data. You look at your data, you'll try and identify missing rules, for example, and you'll try and go through the process of making sure it's clean and ready for modeling processes. Then you do some sort of featureization. That's just a fancy word of just generating features from your data. If anyone in the audience are Kaggle members, have a show of hands. Anybody? Yeah, you'll understand the people who win competitions are best at featureization, right? You generate your features, you win competitions in Kaggles. Model selection, depending on the problem you're trying to solve, you might choose different algorithms from neural nets to simple model like logistic regression, linear regression, lots and lots of different models. So you'll go through the process of selecting your models. And then this comes to the fun part. This part I really like, where you can tune your parameters. So depending on the algorithm that you've chosen to solve a problem, there could be tons of hyperparameters that you can tune and fine-tune to get that right accuracy, to get the best model. And once you do that, you go through the process of validating your model. Well, you first train it, and you validate your model. You'll try and figure out whether your model's good enough for the problem at hand. And most of the time, it isn't good enough. So what happens is you go back to the very beginning, where you start the whole process again of doing your feature engineering, your model selection, your hyperparameter tuning, and that can go on and on and on and on. And when you're happy with it, you then go on to model deployment and prediction, right? But what this slide shows is machine learning, developing machine learning models is an iterative process, can be extremely time-consuming and tedious, but for some of us, it's the fun part. In fact, I met somebody yesterday that said that they tried to develop a linear regression model which took them 2 weeks, which is a long time, and sometimes we're not fortunate enough to have 2 weeks to develop a machine learning model. So, how can automated machine learning help? And automated machine learning can help by just automating all those tasks in the background that's gone away now in the slide. And what it aims to do, it takes your raw data straight to model deployment and prediction, just like magic. So when we started this slide, a couple of slides ago, we spoke about AutoML in terms of trying to solve the problem of lack of ML expertise. But there's more benefits to AutoML than just solving the lack of machine learning expertise, right? It automates tedious tasks, and by doing that, it increases efficiency. And when you increase efficiency, that enables innovation. Even for us, even for data scientists or working for advancing analytics, right? We very quickly use AutoML to generate quick baseline models, and that kind of sets the standards for us in terms of, you know, if you're runners, that's our PB, that's your personal best, and we can always better it. So we always use AutoML to give us that indication on, right, that's the kind of standard, let's improve on that. And that increases efficiency and enables innovation. So if you look at AutoML, what can AutoML do? What can AutoML solve? Oh, I've clicked the button twice too quickly now. So AutoML, I can go back. It can do regression problems. What are regression problems? Regression problems falls under the umbrella of supervised machine learning, and it's pretty much trying to predict into the future. So if you've got problems like trying to figure out how someone will spend on a product, or house prices are going to change, these fall under the umbrella of regression problems. So AutoML can do that really effectively. Then you've got classification problems. Again, if you're trying to figure out whether a transaction is fraud or not fraud. Again, classification is a supervised machine learning problem. And again, falls under the umbrella of supervised machine learning. You can do this very easily with AutoML. And quite recently, what AutoML has also aimed to do is solve time series problems. And here, time series is pretty much when you have data that moves with time. So if you're trying to forecast, for example, the closing price of a stock every day, trying to predict weather, which is very, very difficult, or pollution levels in certain cities, they're all pretty much are time series problems, and AutoML can solve this very effectively. So AutoML, if you look at most of the cloud providers, AutoML can pretty much do guaranteed these three machine learning problems. However, recently, AutoML can also do a bit more advanced machine learning. So some AutoML can solve computer vision problems for us. Now, if you look at computer vision, there's many different tasks within computer vision. So you've got multi-label image classification, where, for example, if you've got an image of a cat, a dog, and a duck, you can pretty much figure out which is a dog in that image. You can do image classification, and that's merely trying to figure out whether it's a dog or not a dog. You've got object detection and image segmentation, and you can do all this in AutoML as well. One of my favorites, you can also do natural language processing within AutoML. So if you've got a large stack of text documentation, for example, and you're trying to figure out the category of a documentation, you'll use NLP to categorize your documents for you. Text summarizations, all that falls under the umbrella of natural language processing that AutoML can solve. Okay, but today what we're going to talk about is AutoML in Azure. And if you look at the AutoML capabilities within Azure, there's pretty much 3 services. They're all cloud-based, and they're provided by Microsoft Azure. They all offer different types, slightly different variants in terms of AI and machine learning capabilities, but they all offer AutoML. And the good thing about all these 3 services is they can be integrated with other services within the Azure bracket. Today, what we're going to look at in particular is Databricks and Azure Machine Learning. We won't be looking at cognitive services. I've got to talk about cognitive services tomorrow. So if you're interested to figure out how we could use cognitive services for AutoML, then please do come for my talk. But today, what we'll look is look into more detail into Databricks and Azure ML. I've got this big competition slide here, Databricks versus Azure ML, but in no means am I having a competition today. I'm just merely picking out the features that I found interesting. And I'm going to compare and contrast each of these features. Okay, so I've divided the sections into kind of 4 main sections. I've also recorded my videos because I know the internet here is appalling. And I know so I've prepared for this. But if it's too fast, and if you want to know a bit more information about it, come and talk to me and I'll take you through it. And we can go through slow internet process. I can take you through how we do certain things. But in terms of uploading data, let's have a look at how we would do it at Databricks. So firstly, well, this is not started for me. Let's just go back. Let's start again. Okay, what we need to do in Databricks is make sure we're always in the machine learning persona. We've got lots of different personas in there. I've chosen machine learning. To upload data, you click on the data, as simple as that. You click on your add button, And what we're going to do is, because we're comparing like for like, we're going to upload a CSV file. So to do that, you click on the upload button, and it's as simply as browsing, telling where your CSV file, where it lives on your computer, opening it up and uploading it. Takes a couple of seconds, depending on your internet connectivity, of course. I wasn't going to do that today and wait here for 5 minutes. And what you do then is you tell Databricks, that's my CSV file, and what I wanted to do is write it to a table. I've called it Bank Marketing Demo. And that is the view of the data set. So that's it. Didn't mean to do that. First row contains headers. And you pretty much go through the process of just making sure the data uploaded looks all right. And that's it. You create the table, and Databricks does all the work for you, takes your CSV file, and creates that table for you. Simple, right? Now let's have a look at how you would do it in Machine Learning Studio. In Machine Learning Studio, similar process, different view. What you do is you set to start a new automated machine learning job. You create your data asset. You call it a name. What I like about this here that I didn't get in Databricks is there's a description, right? If you're anything like me and you work with tons and tons of data, you come back to a data set next week and you forget almost immediately what the data set was all about. So here I have an option to put a description in, just to remind myself what I'm working with. I'm uploading a CSV file, just like what we did in Databricks. You select a data store type. You've got an option of two, either a blob or a lake storage. And it's as simple as just uploading your file. You tell Azure ML where your file lives, you're uploading it. Click on Next. And what happens here is very similar to Databricks. You get a view of your data set that you're working with. You get to see a bit more kind of options. You get an option to skip rows. You can choose different file formats, different encoding if you're working with different file formats. You've got column headers as well, similar to Databricks. I'm not going to skip any rows because I know my data set. And then, yep, you can view right to left, right, just to have a sanity check that that's the data set we're working with today. And if you click on the review button, that gives you a bit more information on the data set. We just didn't see that in Databricks, but that just gives you a snapshot of what you've uploaded and what we're going to work with in Azure Machine Learning Studio. Okay, so just to summarize those similarities, this is what I'm going to go through into every section. So I'm breaking it down because it's quite a lot to go through. In terms of uploading your data set, if you're starting an automated machine learning job in Databricks, you've got to upload your data set before you start your job. Otherwise, you can't start your job. It needs a data set. With Azure ML, you can do this on the go. So you can upload your data set as you create your AutoML job. And what I like about the Azure ML is you had the option to provide a bit of description of your data set, which is very helpful. Okay, now comes to the part we've uploaded your data set. Let's start AutoML runs. So how do we do this in Databricks? You spin up your machine learning cluster. So if you don't spin up a machine learning cluster, you won't be able to run your AutoML experiment. You've got a choice of 3 machine learning problems with Databricks. You've got classification, regression, and forecasting that you saw there. And it's a case of telling Databricks now, I want to use the bank marketing demo data set that we've written down to the table. Check your data set over, and you've got an option to impute, right? So if you know if you've got certain missing values, you can choose one of those 3 options to impute each of your features. Then what you do is choose what we're trying to predict here. And I know we're predicting whether customers are going to subscribe, which is in your Y column, or not. If you click on Advanced Configuration, what you're going to do is set your evaluation metric. You've got a choice of metrics. What I'm going to choose is accuracy. You've got training frameworks as well. I've left that as default. 120 minutes is a bit over the top, so I'm bringing it down to 60 minutes because I don't want to be charged too much. It's not a time data set, so I'm leaving that blank. And I'm also going to leave the positive label blank at the minute. And that's pretty much it. And if with 7 clicks, that's it, right? With Databricks, you start AutoML, leave it to run for 60 minutes, and you come back to it. Okay, so now let's have a look at Azure. Oh, sorry, before we go on to that, what we didn't really see in the GIF file that was recorded, that is that Databricks has got integration with Feature Store. So remember when we showed the machine learning lifecycle and how I explained feature engineering is pretty critical step in developing your machine learning models. With Feature Store integration, it's brilliant, right? So if you work with a group of machine learning engineers and data scientists, that gives them the ability to work with Feature Store where you're generating more features from with your data set, storing it in your Feature Store, and if you're using Databricks to run AutoML experiments, you have your Feature Store integration. So you can go onto your Feature Store and drag in several features that you can use for your AutoML run. So that's a cool feature. So let's have a look at Machine Learning Studio. How would we do this? We've got the data set. It's merely choosing the data set that we want to work with. Then what we're doing is configuring the job, right? We give it an experiment name. A target column again here, very similar to what we did with Databricks. We're selecting the Y column, which is predicting customers if they're going to subscribe or not subscribe. You've got a choice of 2 computes. And what I'm doing, I'm comparing like for like. So I've spun up the same cluster. And all I've done is chose the cluster. And I'm going to have a look at my banking dataset demo. What I can see here is a dataset that I'm working with. I've got 21 columns. All looks fairly all right to me. Go on to next. This is interesting. I've got more tasks than Databricks. I've got classification, regression, forecasting. With classification, I've also got the enabled deep learning, which I didn't see in Databricks, which is really helpful if you're working with text. I've got natural language processing as well as computer vision. So I've got a few more options in terms of what I can solve as machine learning problems. If you look at additional configuration, primary metric, very similar to Databricks. You've got a range of metrics that you can choose to validate your model. So like-for-like comparison, I'm going to choose accuracy. I've also got a choice to explain the best model, and we'll see this later on as well. Here, instead of choosing models that I want to use for AutoML, I can block models in Azure Machine Learning. I'm going to leave everything as default. Again, we got the positive class label. The exit criterion, 6 hours is way too much, right? So I'm going to do it for 1 hour, similar to what we do in Databricks, and concurrency. So I'm going to leave it all the others as default. I save. Featureization settings. So I've got a few more settings here compared to Databricks. As with Databricks, I can choose to impute, and that's very similar. That's almost the same features that I had with Databricks. But what I'm seeing here is I've also got the option to featureize my data. So I've got a few more options there, which I didn't see in Databricks. And it's as simple as that, right? So we've prepared our data set. Oh, no, sorry, we go on to validation. This is interesting. I've got choices in terms of how I can split my data, which I didn't see in Databricks as well. And what I can do as well is tell Azure ML how many percentage of the overall data set that I want to keep aside for testing. And that's really good, right? Because with machine learning problems, what you really want to do is if you've got a data set, you ideally want to split it into training, validation, and testing. So I can do that really easily here with Azure Machine Learning, which I didn't see in Databricks. So in terms of setting up your machine learning, your automated machine learning runs, that's how you do it with Azure Machine Learning. Just to compare it, if you look at Databricks, right, the 3 problems that we can solve in terms of machine learning are your typical classification, regression, and forecasting. Really like the feature store integration with Databricks. But if you hop on to the Azure Machine Learning, you've got slightly more machine learning problems that you can solve, as well as your classification, regression, and forecasting. You can solve your natural language processing and computer vision. Really like the deep learning capability to help with feature engineering if you've got a tabular data set, if you've got text features in there. You've got explainability as well with with Azure Machine Learning. And you've got more options in terms of how you featureize data. And lastly, you're able to specify the type of validation and the test type. So slightly more features, right? Okay, so we've set up our experiments. It's all run now. I'm all done. So we're going to go in and have a look at the results. So let's go back to Databricks. In Databricks, once you run your AutoML experiment, it will be in your experimentation tab, and this is how it will look like. So if you click down on AutoML, what you will see is you've got an overview tab. The AutoML run is completed. So you see a green tick there. What I can also see is warnings almost immediately. AutoML tells me, hey, the data set you were working with, there's some categorical data that needs to be addressed. Severity is medium. And there's other sorts of alerts that's provided to me, which is very helpful. They're all guardrails in terms of, this is a data set I'm working with, this is the problems I'm dealing with, and I just want to be aware of it. The data exploration notebook is pretty amazing. So what that gives you in Databricks is step-by-step code in terms of data exploration in Databricks. Under the hood, they use pandas profiling, which is a great tool if you want to get this sort of HTML reports almost immediately, which would take me days to produce if I'm working with a data set. And as you can see, right, it gives you plots, histograms, loads and loads of different statistics and missing values for every feature that you're working with. That's pretty cool. So what I've done, I've taken my time here in the video and I've scrolled down just to show you the amount of information, right? As we scroll down, there's interaction plots as well. So that gives you the ability to see how each feature interacts with each other. And you can see correlation plots and absolutely all the different types of correlation that's available for you to use as a data scientist is provided here for free. If you've got any missing values, it will also be shown here, and you get pretty much a snapshot of the data set you'll be working with. Duplicate rows, missing values, pretty much everything is given to us. What I've also done is, I think, yep, I've also recorded this. If we go on to more details, it gives you a bit more information, right? You've got descriptive statistics, common issues, extreme values. If you were not using pandas profiling for this, you'd have to figure it out and probably scale that particular feature so it's normalized. What it also gives you are alerts, so you can very quickly look at your data set and just try and get a good feel of what's happening in my data set, what am I working with, are there any kind of serious issues that I need to be addressing. Looks to be all right here. The reproduction pretty much gives us a feel in terms of how long it's taken for us to generate the pandas profiling. I think it's 15 seconds, and pretty much the same thing, right? So that's the data exploration notebook. Okay, I think that's it. A description, yeah, you can write a description, but that's pretty much it in terms of viewing the results in Databricks. Hopping back into Machine Learning Studio then. Very similar, if you run loads of AutoML runs, it will be available to you. Looks slightly different. What I like about it in the Overview tab, you've got loads of information of when it was created, when did you start your AutoML run, how long did it take for you to run it, who was it created by, and loads of this meta information that is just useful, especially if you're in an organization running loads and loads of AutoML runs. You've got a summary of the best model provided to you almost immediately, looking at the overview screen. Similar to Databricks, you've got data guardrails here that shows you the validation split handles, how it was split, how your data set was split. You've got a warning sign there in terms of class balancing detection, which we didn't really see in Databricks. So here it's telling me I've got a class imbalance in my data set. And yes, it looks to be there's a certain imbalance in my data set. And it's just important to know as a data scientist what you're working with. And you've got, well, it's alerted, so not serious. And this gives you all the models that was produced in Azure Machine Learning Studio. You've got 42 models that was produced. It's quite a lot of models within 37 minutes. You've got output and logs where it stores all the information as well. And any child jobs associated with the run are all stored in a single view. And I think that's pretty much it. So in terms of viewing your completed AutoML run, that's how you would do it with Azure Machine Learning Studio. And to summarize, right, with Databricks, what I like about it is I had the ability to look at the data exploration notebook. And if I wanted to, I could take that exploration notebook and rerun it myself. I've got the comprehensive analysis and stats on the data sets. But with Azure Machine Learning, what I really like about it is I've got detailed information about my AutoML run. Okay, so this is interesting. Best model comparison. I've done a side-by-side comparison here. So what I'm doing is, on my left, I've got Databricks, and on my right, I've got Azure Machine Learning. What I'm going to do is compare the best models, right? So on the top with Azure Machine Learning, I've got a voting ensemble model that's provided the best for me in terms of accuracy. In Databricks, it's a light GBM model. But what Azure ML shows here, the accuracy is, well, 0.924 against 0.916. So you might think that Azure Machine Learning is doing slightly better here, but really it's not. Because what you need to do is compare like for like. If you look at the test accuracy score, what you need to be doing is you're going to test results and looking at what was the test data set like. And it's slightly less. So if you look at the test data set and the accuracy score for the testing, Databricks tips it ever so slightly. So you've got 0.916 against 0.912 is very marginal. But that's how you would do in terms of comparison. If you're comparing tests, if you're using Azure Machine Learning, then you've got to make sure that you go into your test results to have a look at how the model did on your test data set. Let's have a look at the best model in Databricks. So with Databricks, it's a glass view approach, right? If you click on the best notebook, it produces line-by-line code for you in terms of all the different steps Databricks has taken to produce that model for us. So as you scroll down the notebook, you can see all the preprocessors that were used, all the different libraries that were imported, how the numerical columns were addressed, categorical columns as well, how they've used pipelines. So everything is provided back to us pretty much from free. I see the test train validation test split here, that initially I had the option to site with Azure ML that I didn't with Databricks, and that's because Databricks doesn't provide us with that option. It does it by a mere 60-20-20% default. And then it pretty much shows you, right, what kind of classifier was used, which is your best model. What I like about it is it's also got the optimal hyperparameter tuning here. And within Databricks, you can, because it's Spark-based, you can always go back, rerun this whole notebook, and use your Spark clusters as well, which is a lot more efficient, and you can distribute your processing. So if you wanted to do this, you'd have to come back and make sure you're just changing a couple of lines. You've got information there in terms of how to do this. You've also got feature importance, but given how SHAP is so memory hungry by default, it's turned into false. But if you wanted some sort of explainability, it's easy enough for you to rerun this code on your own, turn the flag from false to true, and it will produce some feature importance plots for us. And everything else, right? How, because Databricks is integrated with MLflow as well, your model will be registered to MLflow, and you've got some sort of results provided to us. So you've got your plots of ROC and confusion matrix, all given to us for free. And I think that's, yeah, right, okay. So I've got another recording. So because everything with Databricks is hooked up to MLflow, all your parameters are logged for free as well. So you can always go back and have a look at how what parameters are associated with the model. Tons and tons of different metrics that are provided back to us, and everything is logged in MLflow. That's really, really handy, and you'll see why when we come to deploy the model. You get all your artifacts as well logged on for free. And I think that's it. Okay. So let's hop back to Machine Learning Studio, and let's go and have a look at how we would have a look at the best model. So with the best model with Machine Learning Studio, you go onto your model. You've got voting ensemble, which is a great technique. If you click on voting ensemble, you can then see the number of models that were put together to give you that ensemble model. You've got explanations preview here, which is amazing. So you get to see in terms of importance, your explainability of your model. If you're working in a financial business, this will probably be a huge importance to you to be able to go back and understand why those features were important in your model. There's loads and loads you can play with. I've spent half a day playing with this explainability stuff. There's absolutely loads of features that you can look at. And they're all interactive dashboards as well. And because I had so many features, I was having a field day. So as you can see here, you can look at, you can choose different access values, right? You can look at how each feature impacted the prediction. And that just pretty much helps you in terms of if you need to produce a report for the machine learning model that you've developed, this helps immensely. Wish I could speed things up, but I can't. I'm going to wait and see what happens. Right, okay. I was obviously having lots of fun. You can also look at individual feature importance, which I find very handy. So that gives you for every data point in your data set, you can look at what are the feature importance for every single point of your data set. You didn't get this in Databricks as well. And they're all interactive, as you can see. Okay, so similar to Databricks, you've also got access to all the metrics that was provided. The only difference being in here is it's interactive. So you can click and see exactly where you are in terms of certain metrics that you want to drill down into. And then you've got data transformation, right? And that tells you, if you've got a data set, how did Azure ML, what steps it took to create that model? So you've got categorical and numeric, and what kind of steps it's taken to create the classifier for us. The test results, which we already saw previously, and then you've got your output logs, where all your information about your voting ensemble model is stored. So similar to what we saw in Databricks, because under the hood is MLflow as well, you get all your pickle files here, all being logged as well. But you don't get to see line-by-line code. You get all the information logged, but you don't get to exactly see step-by-step how the particular model was developed. Okay. What you get is code in terms of if you wanted to run it again in Azure Machine Learning, how we would go back to MLflow, pull down the model that MLflow has registered for us, and rerun the code for us. So that's what we get. So in terms of comparison, I think the big ones for me, in terms of Databricks, you get line-by-line codes, you get to see the algorithms that we use, and that's immensely helpful, especially if you're starting off in machine learning, wanting to learn how the classifier was built and implemented. Databricks is amazing for that. You get to, if you like hyperparameter tuning, you get to go back and use Spark for free. Produces slightly better results to Azure Machine Learning Studio. What I like about Azure Machine Learning Studio, you get ensemble models as well, and the interactive dashboards is pretty cool. Okay, I'm going to whiz through the deploy model in Databricks. So this is going from end to end. We've gone from raw data to deployment. In Databricks, you've got a choice of either doing batch deployment, which if you're doing batch deployment, super easy. You've got the code to do it in Pandas. What you can also do is do endpoint, so you can do real-time inferring. And to do that, you choose your best model, you register your model. Here I'm giving it a model name. I registered my model. Registration pending, that should take a couple of seconds. Once it's done, you'll get a green tick. And if you move on to your model page, what that gives you the ability is, if you're working in a group of data scientists, it gives you the ability to move the model through your life cycle. So here what I'm doing is I'm choosing that model, and from a stage that it's none at the minute, I'm moving it into a staging, and you can do this from staging to production as well. So once I do that, what I can then do is I can use that particular model that I've just pushed to staging for real-time inference. And what I do is just choose the model version, give it an endpoint name, make sure you're scaling to 0. So that means if you're not pinging the endpoint, Databricks automatically scales your endpoint to 0, so you're not charged for it. And that's pretty much it in terms of deployment. Super simple stuff. With Machine Learning Studio, let's have a look. We've got few more options. So again, I'm going to try and deploy the voting ensemble model. We go on to register model. And again, you give it a name. You give it a description. And this is what I'm doing. And I've got a couple of options, right? So if I go on to deploy, I've got one of 3 options. I can do a web service option. And what that gives me is either using Kubernetes or container instance for my deployment. That's all managed with Azure. But what I can also do is real-time endpoint deployment within Azure Machine Learning. And here I've got manage and Kubernetes as well. So slightly more kind of options in terms of deployment with Azure Machine Learning. And the last option I have is a real-time endpoint, which is just a slimmed-down version of your endpoint. So I think a couple of clicks, right? You can get an endpoint deployment pretty much sorted in Azure Machine Learning as well. And that's it in terms of deployment. So if you look at model deployment, with Databricks, you can work together effectively as a team to manage models through the development lifecycle. But with Azure Machine Learning, you've got more deployment options, as I've shown. And just to summarize the key features, what I really like about Databricks is, again, like what I said, integration with Feature Store. You're able to get those notebook, your line-by-line code for free, immensely helpful for me. I like the way we can collaboratively manage models through the lifecycle with Databricks. With Azure Machine Learning, a couple more options in terms of featureization tools, which I've found handy in the past. If you're solving more than your classification, regression, and forecasting problems, Azure Machine Learning offers you the capability to do that. Interactive dashboards. You're also able to select the type of validation for your data set and the test type, and you've got more deployment options. But I guess at the end of this presentation, right, if I didn't do this, I wouldn't be doing anyone justice. When to use Databricks against Azure Machine Learning? And it's a hard question to answer, and it's pretty much depends. It just depends on what you're after. If you would like to understand and learn step-by-step code that's being generated, if you're working in a large team that you're already utilizing Feature Store and Databricks, use Databricks. With Azure ML, if you need more options with validation, with featureization and model deployment, if explainability is key in your organization, then use Azure ML. But they're both pretty good. In fact, very good. A couple of things, right, with AutoML, in terms of best practices. Every time when you start with AutoML, you've got to start with a clear problem statement, because if you don't, then it's pretty much throwing data into a black box, and that's not good practice. AutoML works best when your data is clean and well organized. So give it the best chance you can give it. Prepare your data the best you can. Feature engineering is critical. It can do basic feature engineering, but not advanced feature engineering. So if you can do this offline and feed it into your AutoML, you're setting yourself up for success. And making sure you select the right model, right? Making sure you understand that certain models are prone to overfitting, for example. So if you don't want overfitting and bias, choose appropriate models. Having an understanding of machine learning models can help. But there are limitations of AutoML as well. 5 more minutes. I'm going to finish on time. So AutoML, like I said, requires high quality and well-structured input data. There are limitations with feature engineering. If you're working with time series data, it's got limited capability in terms of how we can featureize your data. But apart from that, it relies on domain expertise and domain knowledge to do some feature engineering. And AutoML can be computationally expensive as well. So make sure you're turning down your 120 minutes to 30 minutes if you don't need such accurate models, right? How do we get started? Easy peasy. If you're not in Azure, you get free credits. You just go to the link and you start for free. And I think it's for 30 days. Yes, you have 30 days to use $200. Although I don't think that comes with Databricks. But you've got, if you would like to get started with Databricks, you've got the community edition that you can get started for free. This is the end. Have we got any questions? And as I take questions, that's my feedback slide. Please provide some feedback. Questions? Yep.
So, Barry has asked. Seems you need foundational knowledge to configure AutoML to get the most out of it. How can people build this knowledge? Any resources you would recommend?
Yeah, Azure Machine Learning, the help page is immensely helpful. It's got step-by-step guide in terms of how to get started. So I'd say head to its Microsoft Azure help pages. Andrew, I'm going to throw the cube at you.
Is that, sorry?
This Exchange Cube. You spoke about using it to find baselines
Yep.
to build sort of proof of concepts.
Yep.
At what stage do you then transition to something else? Is there any circumstance where that's all you need to do and AutoML is okay? Or would you internally always build something somewhere else with code in a more standard way?
When I say that depends, Andrew. Well, that depends on time. If you've got half an hour to produce a best model, use AutoML. But if you've got a day, and if you're keen on writing your own code, use that as a baseline. Go and play around with other machine learning algorithms. See whether you can beat it.
Yeah, of course.
Hi.
Any other questions?
Yeah. You talked about the imbalanced data set.
Yep.
So is it get improvised by its own, or do we need to do some, as we have to balance the data set, we use some smart and techniques?
You could do, yes. So that would give you, so as you see there, the code with Databricks, it doesn't balance your data set.
Exactly.
Yeah.
So we have to do it manually and then again.
Exactly. So knowing your data set is key, right? So using pandas profiling, for example, understanding what you're working with is important. Mm-hmm. And then if you can prepare it and make it more structured, you're setting yourself up for success in terms of AutoML.
Okay. Thank you.
Any other questions?
I have a question, if I may.
Have a question?
Yeah. So when you've created the pickle files for each of your generated models, how does Azure know what version of scikit-learn to match it against?
It's all logged. So in your requirements file, every single import or library that's been imported is logged.
Okay, so when you deploy it, it will pick up from that requirements file.
Yeah, absolutely. I can show you if not.
Take you up on that.
All
Thank
right.
you.
Okay. Cool, are we on time?
We are indeed. 1 minute.
Well, brilliant. Thank you very much.